someone verify? Can one of you verify that we're live?
Wait a second.
Okay, okay.
It's not showing yet.
It's not.
Yeah, we are live. Yeah, we can start.
Okay, fine. Yeah, I think the stream is slightly lagged, but that's fine. Yes. Um, so hello everyone. I'm Nanda Kovind. We're joined today by Aditya Mangudi, Atharva Sutar, and Arnam Nanal. I'm so sorry if I butchered any of your names. We're going to be doing the EGMO TST questions, which were posted very recently, and the TST happened on Thursday and Friday. So this is just going to be a live. So we're seeing the problems for the first time, and we're trying to have fun with the problems. Okay, so I think we can start now. Do any of you want to say anything specific? We're also joined by Malay and Sai, who will be acting as observers. You guys can add the problems on the Miro, by the way. Okay.
Okay, so for n equal to 2, it's just 1.
1. N equals to 4, it should be like n equals to 4 should be 2, right? Like 3 is 2, obviously. N equals 4, I think we should be able to do it in 2.
Yeah, n equal to 4, we can do it in 2. Yeah, like,
Yeah,
okay, I think in general, we can do 2 to the n and n.
2 to the power n and n, precisely.
Yeah. Okay. So,
And like that should be optimal in K.
yeah, I guess so.
Optimal because that would be like if you had less than K moves, you would have that the subsets chosen could like you look at all K numbers. So now two numbers cannot be in the same group of subsets, right? Like for example, let's like so you have 1, 2, 3 till n. Okay, and now you look at for every one, you just note like out of the K operations that you performed, which all operations was one part of. So say that like for example, if we had like for 3 elements and we did only one move, we would have that if we selected a number, this would have like 1 as part of it. So say that 3 elements and we selected 2 and 3. So then this will be empty. So the point is two numbers cannot have the same subset of operations it was a part of, since that would mean that the two values are the same. So therefore, then subset should all be distinct, but there's only 2 power k subsets, so therefore the number of numbers must be at most 2 power k.
Yeah.
Okay, so n is at most 2 to the k, you can say. Yeah.
N is at most 2 power k,
And for the other part, you can, so we
and
just for this. And we
yeah,
can,
we just have like if yeah, we just yeah,
we
k
can
is
just
at
go
least
both halves simultaneously. Like,
yeah,
and then do what? And then increase the, like, you can just take it like divide into 2 halves, do them both simultaneously and
it's
minus
2
one
power k
operation,
minus 1.
and then add some large number to all of these numbers in one operation.
Yes, precisely.
Yeah.
Uh,
So like
no,
another
wait, what?
construction might be just add dummy elements.
Wait, that's not going to work, right? Because this will be 2 power k plus 1. This will give 2 power k plus 1, right? Because
Right, like I'm proving the 2
No,
to the
no,
k.
like you are adding k minus 1 plus k minus 1. Okay, 2 times k minus 1 plus 1.
But no, that's the point. You do both of the operations in both halves simultaneously.
Oh, you're doing it in both halves
Yeah,
simultaneously. Oh yeah, okay, fine. Then you're doing this in okay, huh.
plus one
Understood,
third is the
understood.
other half.
So yeah, you do both halves simultaneously. So yeah, fine. This works. Fine.
So it's going to be like largest case, smallest case, so that n is at most.
Yeah.
And we can just add happening.
So it'll just be like basically formally the answer will be like log base 2 of n ceiling, right?
Yeah.
Oh god, handwriting is terrible. Yes. Yeah, so that's the P1. Log base 2 of seal of log base 2 of n is the answer we claim. Construction is we proceed by induction on this specific value. Okay, and the point is take a number and like now if your number is 2 power k, then you split it into these subsegments of 2 power k minus 1 or smaller. So if this number is between so so what we know is that 2 power k minus 1 less than n less than equal to 2 power k. So we split it into two subsegments such that both of them are at most 2 power k minus 1. Okay, and in k minus 1 moves, we know we can perform for both of these subsegments. And then in one move, you just add a large number to all elements in this subsegment. So you have that this is all increasing, and then this is all increasing. And because you've added a very large number here, preferably you'll just add the number over the last number in this segment. So then you'll have that the smallest element in this segment is larger than the largest number in this increasing segment. So therefore, this entire segment will be increasing. And for proof of maximality, this is just uh, you look at the subset of operations in which the ith element was part of, and now you'll have that two elements cannot be in the same operation. It cannot have the same subset of operations, which will because otherwise they would be of the same value, and that would mean that it's not strictly increasing. So that will give you this bound here, which is n is at most 2 power k. So that translates to k, where k is like the number of operations. So that gives you that k is greater than equal to log base 2 of n, and because k is an integer, seal of log base 2 of n. So that's P1. Is everyone okay with that?
Yeah.
Okay.
Yeah.
In the meantime, we have P2. Two positive integers are called anagrams. Non-negative integer coefficients is interesting.
So P is like increasing.
P is increasing, yes.
Yeah, P is increasing. So we should just try some examples of anagrams.
P of x equals x.
So I think like for all one-digit numbers, P of that thing will be will be itself.
No. Like for all one-digit numbers, you just have P of A is equal to P of A, which is not useful, right? Because it says whenever A and B are, so this is just A
Yes.
comma B anagrams implies that P of A, P of
Yeah.
B are anagrams. So for like one-digit numbers, the only anagrams are itself.
So like it doesn't make sense.
It doesn't make sense. What you
Yes.
do know is like, so I'm thinking size, because two numbers are anagrams if and only if they have the same number of digits, because you don't count leading zeros, right?
Mm.
So for example, 19 and 91 are anagrams, which means that P of 91 and P of 19 have the same number of digits, and like this basically extends to very large numbers kind of nicely.
We can say that if A and B are anagrams, then P of A is congruent to PB mod 9.
Modulo 9.
Okay, taking the size using the size argument. Okay, but that
Like that size argument is what strikes out to me because eventually it's going to like P is going to grow very fast if it's not linear, right? So when you say that, so like P of the point is like P of 9999 or wait 9 1 1 1 1 1 1 1 1 is going to be far greater than, there's no equality here, P of 1 1 1 1 1 1 9,
So
right?
P of X has to be linear.
but like this ratio, like the ratio is supposed to be like that. It can be as big as it can be only as big as 10, right?
Yeah, this ratio has to be as big as at most 10. But
Yeah,
the
but
point is,
the ratio of the inner numbers is also at most 10.
yeah, that's fine. But I'm just thinking like, so I'm just trying to argue that's not linear. Like, for example, P of X equals X is valid. But the point is that if, P is like degree more than 2, greater than equal to 2, then it's going to grow very quickly, right?
Yeah, that should work.
Like, that should work. Just have to work out like the details. But yeah, that's what strikes out to me. So we're going to make the ones nice.
So if you just look at P of X upon X to the degree, for large X is close to a constant, right?
Yeah. The large X, this will be like leading term.
Yeah, so if you take these two large numbers, because then so the two large numbers you can take as like x1 is
Mhm.
like 91111 and
Yes. So basically limit as X
yeah,
approaches to infinity, we
so
equals to constant, which is a, what is it? A n, like a d. Okay, previous d. So yeah, point is p of x1 by p of x2 will tend to will tend to wait as
okay, we can just write it
limit
like
as n tends to infinity, where like will tend is equal to yeah, this will grow unboundedly, right?
not unboundedly, it will grow, it will become
uh yes, the point is like it will be very close to, well, this will be very close to, yeah, 9 power d.
because
Yeah,
it's going to be like we can write it like this, I guess, like p of x1
yeah.
upon p
Point
of
is 9 power d grows very quickly.
wait, 9 wait 1 second, like it's something like this, right? This is
uh
going to be constant.
oh wait. Oh yeah, what am I saying? Yes, it's going to go to 9 power d.
It's going
Huh.
to 1 actually, yeah. So if
Yeah,
it x1 by x2 goes to 9. So,
x1 by x2 goes to 9. P of x1 by p of x2 goes,
but it should be bounded by 10 though.
it's bounded by 10. Yeah. Okay, yeah. This thing,
So that gives
yeah,
that
this is bounded by 10. Hmm. But this thing is bounded by 10. So p of x1 by p of x2 is bounded by 10. Limit. Uh, well, this thing is always just no limit is less than equal to 10 for all x1 comma x2. This is assuming that x1 and x2 are numbers of this type. Uh,
like they're
1
like
followed by a 9 and 9 followed by a bunch of ones.
okay, so this proves that it's linear.
This proves that it's linear because you'd have that if d was more than equal to 2. Yeah, so this implies linear, which implies 9 power d is 9 power d uh,
That most
less than equal to 10, which implies d is less than equal to 1. Okay, so obviously d cannot be 0 because we're told non-constant, which implies that d is equal to 1. Okay, so now we just have to check for numbers of ax plus b form and
yeah.
like non-negative
Coefficients.
coefficients. Non-negative integer coefficients.
Okay, we can also look at numbers like these, I guess. For example, if p of x has all same digits, if p of x is equal to 9999999, for example, x can't have
Yes.
any anagram, so x must have all the same digits as well. Or it
Yeah.
could,
Or like, yes. That's true because we know it's linear, so you can't have two different roots. Like p of x cannot be equal to 999, and p of y cannot also
and also
be.
like it's increasing, right?
Yeah. Oh yeah, it's also increasing. True.
Um,
True. Yeah.
but can we ensure this correct same digits? Yes, it's the numbers are the form ax plus b. Hmm.
See, but the point is, will all same digits have solution? Like, you want to look at the numbers modulo a, right? And you
Yeah,
want that,
all numbers modulo a occur.
yeah, there'd be all b modulo a. Like what I'm trying to see, times 10, times 10. So what you're basically doing is you're multiplying by 10 and then you add 1. Right? Not add I. Ten x is also, point is like 10x would also be, what do you say?
10 to the kx works.
Kx works? Does
No,
2x
10 to
work?
the kx.
10 to the power kx works.
Yeah.
Yes.
Yeah.
Yeah.
I think we can put some kind of bound on a by considering numbers of the type 900 and 1009. Because then p of this, if a is like if a has the first digit like 2 or more, then I think this would have more digits than this.
Yes, that's true.
So I think we can assume that the first digit of a has to be 1.
We won.
How do we like?
Yeah, because like B can be ignored or
Yeah,
a
we
high
can take a
number.
big enough power of 10, like we can take enough zeros to ignore b. Yeah.
Yeah.
Yeah. But I'm trying to see if we can like show b has to be 0, right? Because surely, like, I don't think allowing b would be nice.
No, B can be non-zero, right? For example, consider 10x plus 3. Like, it just shifts and adds a 3.
Oh
That would
yeah,
have...
yeah.
But we can ignore b for our consideration. We can just multiply x with the power of, we can just take like a 10 to the
Yeah,
second.
yeah. No. What you're saying is correct. Like, I was wondering whether only numbers are of the form 10 power k times x. But clearly 10x plus 3 is valid.
Okay, so we should prove that a is a power of 10. For example. And this should work, I guess. Like we can take 9001 and followed by a lot of zeros and 1009 followed by a lot of zeros.
But then all that tells you is that A has to start with 1. How do you argue for like?
I think we can extend the argument by like, I mean, I'm not sure exactly this works, but if you have like something greater than 1, like, sorry, if you have 10 to the k plus some small number, by making numbers of this form, you can eventually prove that p of 9001 has like more digits. I think numbers of the form 9, we could work with these kind of numbers.
And then you have 10999999.
Yeah, which is like
We
quite
can also
small.
put more zeros.
Is that true though? But 9.
Okay, we can like take the numbers better. I think like we can
Oh
take like
yeah, that's true.
we
What
can
you're
take
saying is true because, huh?
I was saying we can do something like this. We can put enough zeros so that the other number is surely not going to raise in digits. Like
No, no, no,
Yeah,
no.
a
What
single
you
digit.
actually want is this type of numbers because the ratio of 10 power k or like well, like this into x, right? So like the point is
This is the
whatever is this
bottom
thing.
number is like 10999, which is like less than 11,000, and this is I think greater than that. So like the ratio is,
Hmm.
I
The
think
point,
it tends to.
yeah, the point would be that 10 power n, like if this is n digits long, if this is n digits long, 10 power n by numbers of this form x, this would tend very close to 1 as we add more and more nines. As
yeah.
And yeah, we can like add a few more zeros here to like decrease the ratio of.
Okay, do we want to we want to increase the ratio though, right? Or no?
no, decrease the ratio
No,
of 100.
yeah,
Like if you, but I highly doubt that really matters because just less than 1 followed by a bunch of zeros itself seems pretty nice.
So what we
But
want
the
to do
point
is
is like,
number of digits change, right? So I think we might need to add a few zeros.
Hmm.
Accordingly.
we might.
And it's no
What I'm
harm.
thinking is
No
10
harm in
power.
zeros. We can just add zeros.
Like, wait. The point is 10 power k plus something, right? Like epsilon. If it's 10 power k plus epsilon, then because this limit tends to 1, what we can basically do is that we just take sufficiently large n so that this epsilon by 10. Okay, wait. What we want is 10 power k plus epsilon by 10 power k is greater than 10 power n by x, where like x is this thing. 10 power n plus, yeah, 10 power n. This should work, right? Like this will cause this to go to the next digit, right? Because you'll have 10 power k, like this is completely ignoring b, but this will be like 10 power k times epsilon. I mean 10 power k plus epsilon times x is greater than 10 power n plus k. So this will mean that this will be an n plus k plus 1 digit number.
Yeah. You should.
Yeah,
That should be fine.
Yeah.
This should be fine, right?
And we just need to ensure one. Okay, I think adding more zeros in between doesn't harm, so we can just add it. Like, why not?
Like I mean I don't like, all we really need is that this limit should just tend to 1 because I just use the
Also
fact
need
that
the
Because
I
this
can
will then
big,
tend to 1. It is of course very
like we also
wait,
need the
what are you
other
considering
number
as
to not
10k
store.
plus epsilon?
like 10k plus epsilon is
The
a,
number. Yeah.
like this is
Okay, okay.
a by 10 power k. So like this will be an n plus k digit, and we also need to simultaneously verify that uh, 10 power k plus epsilon times like the 10999 thing is less than 10 power n plus k, which should surely be true. Why is
Like
that
if
true?
it's not true, we can just add a few zeros over here to make it true. Like
Yeah,
we
because
can
like
like
the number of
do
we
Yeah,
can
this
add,
yeah,
and then compare. We can
I
do
think we can
this
add like
by adding
10 zeros
zeros,
and
go there by adding sufficient nines.
I'm just trying to see if this just works directly because I don't feel like adding zeros. But yeah, I think like you
Is
can just
the
pad it with zeros anyways.
exactly
Like,
why not?
Yeah.
no harm.
Huh. Sure. Yes.
Like if you
Yeah.
add like
Yeah.
n zeros and two n nines, so then it doesn't affect the nines.
Hmm.
Mm-hmm.
Like we can first add the zeros and then add how many nines we want.
Had how many with nines we want. Yeah. That's true. And because you can, yeah, that works. I think
That will
then
prove that epsilon is not possible, and then
epsilon is not possible. So now you have that its numbers of the form 10 power k times n plus b
So now,
times
like, we
x.
just need to show b cannot be greater than or equal to 10%.
Yeah.
And we know B is at least 0. That's good.
B is
Yeah.
b is positive, like non-negative.
And,
So like this is just x 0 0 0 0, right?
hmm. And we
Like
if
want
we
that's just, and
assume
then you just have plus b. Like this is our number. So now the point is we want that b better fit into this slot of
so
numbers.
we can assume that b equals 10 to the k minus 1 plus something.
what?
Like we want
Oh,
to prove that b is less than 10 to the k, right?
yeah, so okay, 10 to the k plus something. Yeah.
Yeah.
Yeah. Okay, I think something like this would work. Like we take 1, 1, and then a lot of zeros.
Uh-huh.
This is like unaffected by B, and 1, 0, 0, 0, 0, and then a lot of zeros, and then a 1.
One.
That one should
So
like,
now,
okay, that
yeah.
one should be placed at the end. It should be placed at the leading digit of B. Not over here, but
Mm,
somewhere over here.
yeah.
That is like the leading digit of B.
Okay. Okay. And now what happens is that B will edit this.
Yeah, like this one is just.
So like this entire segment will be the exact same. Like
Yeah.
yeah, that works. That works.
Yeah. Yeah. So b has to be
Yeah.
leading
So
digit
B
of
will
b has to be less than 10 to the k, I think.
yeah.
Yeah.
Leading digit of B has to be less than 10. Okay. So then that, and obviously all numbers of that form work. Uh, yes. So then this will be, this one's nice. So then this will be all 10 power k plus b, 10 power k times x plus b, where b is less than equal to 10 power k. B is strictly less than 10 power k. Okay. And this is equal to p of x. This should be all such functions.
Yeah.
And this is because we have linear from this size issue. And then we have that leading coefficient should be 1. And then this epsilon thing to show that it better be a 10 power k. And then this argument for leading digit of b has to be less than 10 power k. That's it, right?
I think we're done. Yeah.
We're done. This was nice. So next is the next question on the board.
Yeah, it's.
Oh, it's all the way at the bottom. My bad.
No, follow me.
Okay, I
Yeah.
can come for P3 because I've not done P3, so
Oh, it's Geo. Oh no. Wait, in a bit of trouble. Um,
Very.
What is dot diagram?
Q is interesting.
Okay, AQH is 90 is the point. Okay, so just EH parallel to BC and AC and FH parallel to AB.
Wait, don't draw isosceles.
Wait, where did isosceles? Oh no.
Wait, Nitya, are you doing a diagram?
Yeah, I tried using the smart drawing tool that they had. It made it isosceles. Yeah, my brain glitched as well. We're probably just going to do the. Mhm. Wait. Can we make the diagram a little bit bigger?
Yeah, okay. Can I, how will it look if I just expand it?
Oh wait, C got deselected. Uh, just ensure that if you oops, ensure that if you select, manage to select everything. Yeah. Okay. Is this fine?
Yeah. Okay, so you have to prove, you have to consider circle EF, the second intersection of AH with AEF. You have to prove it lies on OQ.
The diagram is bad.
Yeah, the diagram is, but it's okay.
It's fine. It's fine. This is what we deal with when we are not allowed to use GeoGebra.
Yeah.
A Q H
Okay, maybe I'll try
290.
to make a different diagram, except it'll be hard because I'm doing it from with the mouse.
You can probably use that smart drawing tool that they had. I was trying to use that. If it will let me make a non-isosceles.
But I
No,
think
it made my side a curve. Wonderful. Can we? No, stop making my triangles isosceles.
Okay, I see. This is better. If you're fine with this, this is better.
Uh,
Like,
where are we? Where are we? OMG. Yes, that is indeed better. This is a very
this is
colorful diagram.
very skewed. This is, wait, let me choose a different color. Q. This is
AQ and
O.
A.
wait,
You have to do
Yeah, OQ and AH have to meet on the circumcircle.
OQ. This is, wait, this is E. I think this is E. This is F.
Wait, OQ. Oh, wait, on AEF. Yes.
Okay, first thing, like, because
diagram, you can use that.
CHC and CHF add up to 90, add up to 180. O and H are isomer conjugates in EFCB.
Uh,
Like,
Yeah,
because
it's a quadrilateral with isosceles conjugate.
yeah,
yeah,
yeah.
because angles about H add up to 180, H should have an isogonal conjugate, and looking at angles B and C, it should be O. So we know angle EOF. Okay, that's good. So we know EOF is 180 minus 2A.
Hmm.
We should probably like angle line.
And we know angle EHF would be A. And this, okay, intersection, call it X. X, I'm defining it as AEF cap AH. Angle EXF should be 180 minus. Yeah. Wait, why is Q coming in though? Okay, wait, let's just extend Q to
Wait.
A dash, introduce A dash.
Hmm.
Wait, what's okay? A dash is here. Hmm.
Yep. What do we do next? This is 180 minus A, 180 minus 2A.
We want OQ.
How do we?
Is the diagram final? Like I've done other diagram.
Sorry?
Oh, we have more diagrams.
Um,
I will also make a diagram then,
no, this is. Oh, okay. What I was thinking is consider the harmonic bundle A dash, O infinity. This is -1. And you project it, like, I don't think this is a good idea, but like project this through H onto line OQ. Like A will go to X. We want this to go to X.
Hmm.
A dash goes to Q. This is X. A dash goes to Q.
The
O
infinity
remains at O.
is
And infinity goes to some point. Maybe not exactly this thing, but something else might be good.
You're projecting the harmonic bundle about which point? About
H.
H.
Creating X.
Onto the circle. So A dash was Q. A was to X. X is your okay. Wait, where is O good? Wait, what are you projecting it onto?
Onto the line OQ, we want to show that one point is Q. Like I don't think this is
Oh,
the
okay.
like
What have you defined X to be?
H will go to. Sorry,
No. What have you defined X to be?
X
X
is A
AH cap H cap AF.
Okay.
One more thing we can maybe use is that AM is supposed to be parallel to AH is supposed to be parallel to OM, and like we have parallel line stuff like QXO.
Right. Oh, right. Yeah, that's good. Okay. Yeah. Okay. Uh-huh. So QXO. Uh-huh.
QXO.
Wait, you just have parallel lines XH and OM, and you want to show that they conquer on the circumcircle.
Yeah.
XH parallel OM, and you want to show their intersection lies in the circumcircle. I see.
Hmm.
Okay, that's good.
That gives angles, but
Mhm.
find the other intersection of OQ and AF maybe. Maybe that's
Oh,
better.
Q and
wait, how will you bring in E and F? That's the issue.
Hmm.
hmm.
E and F seem a bit random at this. Can you?
So can we see something about the power of H with respect to AF? Because HX is something you can compute maybe like easily.
Yeah, that is what I'm thinking. Like, if you can compute HX, then the point is you just have to show ki HX over OM is QH over HM, and all other lengths are probably fine. So,
H.
uh, the power of H, the center will make angle.
We don't know the direction of EF, right? Or do we?
See, the
Yeah.
center will be concyclic with O. Like, whatever is the center of that,
Oh, right. That's good.
MOE will be concyclic.
Yeah.
MOEF?
Yeah. That's not M.
Yeah.
Let's call it O dash.
O
M is
dash.
already the point.
M is ultimate point. Yeah, we should probably start making.
So can we compute the direction of EF?
Yeah, that's what I'm thinking too.
Can we compute direction of?
EF. So AH is like the median. Yeah, AH is like the median in triangle AF. That's not.
Wait, OE and OF are not tangents, right?
Wait, but wait.
This shouldn't be.
But they are.
What
I
are the
think
angles?
they are. I think
Why are
because
they tangents?
like AH is median in AF, right?
AH is median in AF.
Yeah, parallelogram. AHF is a parallelogram.
Oh, wait.
Like HF
Ah,
is
right, AH. Oh, right, AHF is a
Oh,
parallelogram.
so O will be symmetric.
the AO will be
Oh,
median and angle conditions give it.
Yeah, exactly. Okay, great. So OE equals OF, and you have tangents.
Oh,
So
Okay, okay,
maybe
that's
pole
better.
polar stuff maybe.
polar should work. Yeah, that's
Okay, now it's also better because like okay, okay, okay. Wait, what if we wait even the if what if we introduce a second intersection here? We now know that that cross ratio will be -1.
Oh, okay. Yes. Okay, we project from A onto something.
Yeah, project from A onto circumcircle.
Wait, so
Oh,
what?
wait, what?
Q.
The
What?
sec the second one should lie here. Second one should lie here.
You mean
No,
it's
wait, what?
you mean in Q?
That's
You mean
weird.
QAF cyclic?
no, no. It's the point that will be harmonic with BHC, right?
The B
In that
put C. We put
That
intersection
is Q.
Q,
that
and
is
then
Q.
That is Q. Wait, it is Q, right?
wait.
Is it?
Wait,
Yeah,
what? Why is
like
huh?
Wait, what?
Wait, what? How can that happen?
it is Q, but I think pretty sure it's Q.
Wait, that point lies on
AQ
AQ
and
as well as
OQ
AQ.
intersect on the circle.
Q is on a
And
circle.
Yeah,
Q
QAF
is on
Q
the
does not.
circle.
Yeah, wait, then Q must lie on the circle. No, but
yeah.
according to the problem, we haven't proven Q lies on the circle.
No, no. Oh, yes. We haven't proven Q like this.
Yeah.
So let's
We
prove
have to show Q lies on the circle.
And then we would be done, right?
Yes.
Yeah.
We
Yes.
should be done.
Okay, we just have to show Q lies on the circle.
Is that
Ah,
true? That seems very
But like we have a
yeah,
yeah.
proof.
But
yeah.
yeah, it's correct. Unless we are messing up the harmonic, but yeah, I
Like
think it's true. It's true.
like
Yeah, it's
inflection
true.
across
It's
M.
true.
Inflection across M, right? So it must be true.
Yeah.
Yeah, it's true. Like we just have the seva minus, whatever.
Uh-huh.
Yeah.
Q lies in A.
So we want to just show Q lies on the circle.
Oh
Yeah.
wow. Okay, okay, that's nice. AQ. Oh, that is not a claim I would have thought. Like it feels false at the start.
Yeah. I mean, yeah.
Okay, the center lies on the line through O and the midpoint of AH.
Line through O and midpoint of?
Yeah, it's like midpoint of AH and O are both on the
Yes.
perpendicular bisector of AQ, right?
Yes, because midpoint of H is midpoint of EF. Okay, wait, let's just make that.
What about midpoint of AH, midpoint of EF, right? Wait, so we are done, right?
Wait, what?
What?
Right,
Midpoint of
because
EF is on the perpendicular bisector of AQ. O is on the perpendicular bisector of AQ. So O and the midpoint of EF.
yes, nice, done. Great. That's nice. Okay, did you understand the finish?
No.
Okay, so introduce the midpoint of AH, which is also the midpoint of EF. Call
Yes.
it.
Yes. Yeah.
Yeah, so the point is like the second intersection of AEF and ABC will be okay. Call midpoint of AH as this. Call it N. Okay. So
Yeah.
the second intersection of ABC and AEF will is the reflection of A in NO, right?
A
Good.
reflection of A in NO.
No, or you can
Because
state it like this.
Yeah, because I will preserve both of the
Or you can state it like this better. Maybe like N lies on the perpendicular bisector of AQ, right?
analyzer
yeah.
perpendicular. Yeah.
Because it's midpoint of AH.
Mm-hmm.
O lies on the perpendicular bisector of AQ. So ON is the perpendicular bisector of AQ.
Yes.
And ON passes through is the perpendicular bisector of EF as well. Because O
And
is the intersection of
because that is midpoint of E and
O is the intersection of tangents. And N is the
oh
midpoint.
yeah. O is intersection of tangents. Yes.
Oh
Yes.
wow. So
EF
actually
is
AQ is parallel
Oh,
to EF.
AQ
AQ
is
is
the
bad.
isosceles trapezium.
Oh damn.
Oh,
That's
damn.
actually cool.
And so that's
Okay.
like pretty
Fine. Okay, that is way too clean. Damn.
Yeah, that's nice. That's nice.
How long have you spent?
I don't know.
An
I think
hour. And less than an
I think
hour because you
P2 took
started.
time. P2 is just like I think too many details.
Yeah, P2 would
Mm,
have
yeah.
taken time. He had
I
to
mean,
write.
we still did like we didn't work out some of the algebra too. Like
Yeah.
we just said limit just tends to this thing, and we're just going to believe that.
Okay. Let's move on to P4.
Hmm.
Yeah. Oh, P3 is nice. Mm.
I have posted maybe just follow.
Positive integer m. Let fm denote the smallest one. Not less than m. So greater than equal to. Can they not say that?
Wait, so is it sufficient to say that consecutive differences are at least f1? Or is it better to look at the farther
1 by f1.
1 by f1? Yeah. Or is it better to look at farther distances? Yeah.
I'm thinking. By the way, what would be f of 1 by 2025?
What?
F of oh wait, no, it's for positive integer. Oh wait,
Oh.
okay, that's fine, it's fine, never mind. Uh, okay, so eventually this thing keeps shrinking, right? So the gap doesn't need to be too large. In 0 to 1 is the point.
This one is a 4 point.
So see, x2 minus x1, so that's 1 by 2024. C has to be less than 2024 then. What about replacing 2024 with some 2? Like, can we see what happens then?
Hmm.
Like just small case check, right?
Hmm.
Like, does everything less than 2 work? See, C equals 1 for 2 would go like 0, half. Okay, then you have 4, right? So I can go increase by 1/4, increase by
That
1/4.
converges, right? Half part plus 1/4 plus 1 8 converges to 1.
No, it won't be half plus 1/4 plus 1, will it? No, you'll be adding 1
Consider this equation, right? Xn is equal to half plus 1/4 all the way till.
1 by, no, but that's too small. Like x4 minus x3 would also need to be greater than 1 by 4. You'll be adding half plus 1/4 plus 1/4 plus 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8.
You're right, right,
1
right.
doesn't work.
Hmm.
1 doesn't work.
We're not sure yet because like it doesn't need to be increasing. It can go like weirdly.
Haha. Oh wait, it 1 does work. I mean 1 does work because you just go half, okay, plus minus 1 by 2 minus say yeah, plus, so you go 0, half, minus quarter, and then you go 1 8 1 8 1 8 1 8 1 8. So you will be
Like this.
adding all the odd powers. So yeah, it'll be 0 and then you'll have 4 1/8s.
Okay, okay. So like this you mean like 1 by 8. Wait. So 1 is a bit too weak. We can do 2.
2, we can do 2 because you go 0 1 minus half, and then you go plus 1
So like
4
this.
plus 1 4 plus 1 4. Yeah. So you can do that. So for 2, what we can do is like, wait, I'm just making it for 2.
Hmm.
You do go to 1, then you go to half, then you go to 0 again, then you go to 1/4, 2/4, which is half,
In our
3/4.
sequence,
1 or what,
wait, like,
4/4.
what if you take m equals 4 and n equals 1? Then, like, this is 0,
M
but
is
this
M
is
is 4
positive.
and it's 1.
This is for like replacing 2024 with 2, by the way.
But
Yeah, but
that still doesn't matter. This is going to be 0, so like c by f
Yeah.
of 1 has to be 0.
yeah, like it's M greater than N, not N greater. Like
Yeah,
yeah, this doesn't work, right?
the sequence has to be increasing. Not increasing, but like,
So it has to
Oh,
uh,
be
wait.
distinct.
I see what you're saying.
It has to be what? Does it
you,
have
you
to
It,
be?
can't
it
Oh,
cannot
repeat.
repeat
it's not for
things.
consecutive elements.
Okay, it can't be repeating. Fine, yeah.
Yeah,
Correct.
you can't have 2 repeat numbers.
It's
Does it have to be
injective.
monotonic?
I don't think the monotonic will be condition. Like
Hmm.
maybe not.
Because numbers after M can be close to M. Numbers before M have to be farther from XM.
Yeah. Oh, for one you can do this. For one you can do this. For c equals 1, you have 0, you have half. Okay, now you have 1/4, 3/4. Okay, 1/4, 3/4. Then you've got 1/8, 3/8, 5/8, 7/8. Dot, dot, dot. This is for c equals 1, 2024 equals 2. You can do this. Because like these elements just want 1/8 distance from everything else, but that's completely fine because everything else is like a fourth, and like the 16th will have their own section. Same here, same here. But it won't be monotonic or any of that clearly.
Okay, wait, yeah, this works. Yeah. Wait, 1, 2, 3.
The C equals 1 works, right, for
C
2024 as
equals
well.
1 works. And now we probably just want to show like something like c greater than 1 doesn't work because this clearly like fills almost everything.
Does C less than 1 work?
Yeah, obviously, like because the
Oh,
same
yeah, yeah.
sequence,
You
same
just use the
sequence will
same
just work.
sequence.
Yeah, so c equal, so like even for the 2024 case, c less than equal to 1 works. 2024 case too.
1.
Huh?
Is it still 1 or like can we do? Wait.
No, 1 works because like you take I think 1 by 2024 to
Yeah, you take 1 by 2024 till like what do you say? 2023 by 2024, and then
yeah,
you do like 1 by 2024 square, 1 by 2 by 2024 square till like
Here.
2023 by 2024 square, and then you do 2025 by 2024 square. Like it's basically like you can look at this like we're splitting the number line into 2024 partitions. Okay, and then each partition we then split like 2024 times,
Mm.
and
Yeah,
like
but
you do that.
this construction a bit different. Like it 1 by 4, 3 by 4 is fine because 1 and 3 are both co-prime to 4. If you take 2024, you're going to have repeats.
No, that's fine. You don't need like co-prime. You just need that it's not divisible by 2024.
yeah. The point is that the on the number line, the distance between 2 points
Yeah,
should be at least
you look at it
1 by
like the
2024.
distance between points. So you have this. Now you're 1 by 2024, 2 by 2024, dot 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 till 2022 by 2024 and 2023 by 2024. And that's your 2024 elements, like from 0 till 2023 by 2024. And now for like the next elements, you'll have 2023 elements in the 0 to
Yes,
1
yes.
by 2024. You'll have 2023 elements in this segment and so on. And so you'll have 2023 into 2024 elements, and you have like 2024 elements done. So that's 2024 square elements. And
Okay.
then you do the smaller partitions and so on.
Yeah. So C equal to 1.
Yeah. So c equals 1 works. And obviously, if c equals 1 works, then c less than equal to 1 works because the same sequence will be less than equal to c, will be less than equal to 1 by fm, which will be greater than equal to c by fm.
Hmm.
And that's just going to be about
I guess for C more than 1, what might happen is the numbers might fall out bigger than 0 or 1.
Hmm.
Is
You
That's what
use
you
a
want.
similar gap kind of method to prove greater than 1.
Okay, wait. What if you look at these numbers? Like, um, just look at these numbers x1, x2, all the way till x 2024. Any two of them have to be at least c by 2024 away.
Yeah,
So the total distance between them has to be at least 2023 into. Yeah, we can just do this, right? This is
Yeah,
just
yeah, yeah.
these
That's what
numbers.
I'm saying.
Gap has to be at least
Yeah.
this much. So
2093 times C by 2024.
okay, like in general, if it's going to be like
Oh
Yeah,
yeah,
okay,
we can look at the first 2024 square numbers and
yeah,
like
like
you know that the
hmm.
gap between any two of them have to be at least one C by 2024 square.
Yeah.
Yeah, so I think
The
we
general
can.
argument
Yeah,
is this, right?
the general argument is just that.
C
Yeah.
yeah,
is
minus. Yeah. And that forces C at least one because this limit goes to one. Okay,
yes.
nice done.
OMG, so many limits questions.
Yeah, so this one we get finally.
Yeah, yeah. And this versus C has to be.
So I think we're done with this, right? Because
We're done. We're done. We're done.
yeah, okay.
Nice.
Now we need fifth question.
Why is the question just continuously just going down, 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 down? We're going. Okay. If I... Oh, it's long. Is it combi?
Another geo.
Oh no, it's geo. That's so disappointing.
I know. It should be
Sorted.
possible.
Wait, draw the circumcircle. Like,
We're going to need
right?
line. Your line's a curve. B delete.
Wait, what diagram are we using? Yeah, like too many diagrams.
Yeah, everyone just make a diagram. We pick the best one.
Yeah.
Like circle,
We
midpoint.
have the same points again. We have Q again. We have-
Really?
yeah. Q don't have E and F, but you have Q and M and stuff.
Yeah.
Let's just introduce E and F. Fun. Okay. Q and let me see one like that.
Where's X? Okay, AM exception.
Oh, they actually figured out I wanted a circle. No. A circle's an ellipse. And then we're just going to do. Wait, no, it's not. Yeah. MX intersection with omega.
Yeah, and for obvious reasons, I won't contribute.
Yeah.
Yes.
Dude, where is X? Where is Y? X is. Dude, why are you drawing line QI?
It's actually not a line, it's a circle, but
Wait, AM omega is. Oh, okay. Okay.
I think let's go with the other diagram. Where is the other diagram?
Okay. Then that's right.
I'm still constructing it. I'm struggling with the drawing bit.
Wait. I'll try like delete the line.
Wait, we sent the line a little too far. Wait, this is so
Like,
cool. I can like do it like OMG, this is literally GeoGebra, guys. Like this is so cool. Um, what else do I have to construct? I've constructed X. EF is feet of perpendicular. Okay, that's kind of easy. Surely.
okay, that's not easy.
Okay, that is not perpendicular.
It is not perpendicular.
Not perpendicular.
Like,
Like this seems
oh,
perpendicular.
that's true. Oh,
And Q
Oh wait,
will
why
be
is it
like,
passing through O? Oh
X
no.
is equal to BC.
I don't think that's O, guys. Like that's not O. Trust me.
you
We're just
don't
gonna say
require oh no, I mean right now.
Oh,
You don't
there's
require, oh, that's true. But AC equal to BC in a diagram.
AEF passes through H, right?
Yeah, AF passes through H, yeah.
Okay.
Okay, and we have this point X. Okay, X is the bottom point.
X is here.
QB second intersection of AEF and okay.
What do you want to show? We want to show BFYS cyclic and CYS cyclic. Okay, maybe define Y as that, that seems so much better. Where is E? E is on EC.
Observe in both geos you have AQEF cyclic.
Yeah,
Like in the others,
E-
you don't know AQEF is cyclic because I had not tried the problem. But yeah.
Wait, isn't Q the second intersection of circumcircle AEF and omega?
Yeah, it's the Q point.
Yeah. Okay.
Yeah.
E is on AB.
Like not,
Wait,
not in
what
the
did you
base.
say that AQEF cyclic? Because isn't that like
Okay,
Are
I
in
know the
the, like
diagram.
last problem as well, even though they're
oh
different, they're still cyclic.
okay. My
And
bad, my
it's the
bad.
same
Now
Q and the same.
I'm done with the diagram. I think we can work with that.
OMG, we have diagram.
But which diagram are you working in? Are we working in the
This is like good enough.
Why is like this? I mean, why is defined
Mine's still on
weirdly?
like Q is second intersection.
Okay, Y is I think it's wait, that's Y, that's not X.
Oh, right.
Yeah, I think the right diagram is right.
Okay, so the only thing I can think about relating Y is that QM is angle bisector of
Yeah,
XQM.
I think we'll first look at BFSY cyclic that property. That seems much better. Or maybe not. Okay.
Y be point such that mx equals my. Mx equals what is x? X is am intersection omega. Fine. That's x. And
Like draw,
QMXY cyclic.
draw the circle and the
Arguments.
Okay, so it's just the reflection
Okay,
of
okay.
what
One thing is
x
first.
about
First thing is this: like,
OM.
if you extend AS to this point, then MX dash is I think equal. MX dash is equal to MX because X dash is supposed to be parallel to BC, right? Right.
Okay, there are 2 pointers.
What?
There's a x. This is x dash. This is x dash.
Okay, that's X dash. Yeah.
Okay.
X dash is supposed to be parallel to BC, right? Because AS AM isogonal. So
Yes.
equal to MX dash equal to
Yeah.
MX. Yes, you want to show that these three circles are concurrent. Okay.
BFS. CF. Wait, what's S?
S
S
is
point.
median.
Oh, S is median. Fine. Ah, okay.
Yeah.
So that
S is
BFYS.
yeah, that's better.
BFYS. Like you want to show BFS, CFE? No, yeah, CSE. Yes.
Also, AF Y is supposed to lie on AEF by Michael or something like AFE, BFS, and CES concur, right?
Uh-huh.
So Y is supposed to lie on AEF.
Oh. Hmm. That's a lot of concurrence.
Like those three concurrences, like right? We just need to prove that point lies on two things.
BFS and CSE.
No, like
Oh,
we can take AFE, BFS, and CES to concur on Y because that point we know lies on this.
okay, huh. And
We
now
want
you
to
just
show
want to
that,
show that that is on QMX.
yeah, or you can show that MX equal to MY and QM bisects YQM. That's all we need. Right? QX. We need we need these two things. QM bisects angle YQX and MY is equal to MX.
Wait, that is given.
That's given, I think.
No,
Yeah.
no. We're like phantom pointing it basically. Like we're
Okay.
having
And
this.
bias AF intersection BFS intersection CS.
Oh,
CS.
so this is Y dash.
Yeah.
Yeah, effectively, but like we
Oh,
pretend it's Y.
Right dash.
Okay, and now just want to show us QMX.
Okay, like now we have a lot of angles we can compute easily. I think.
X in XQ.
So y dash qm
What's some collinearities with Q, by the way?
qmh.
QHM is going.
QMH, right? So,
So y dash qm is
or
equal
not.
to y dash qa.
I
Okay,
think we also
right.
need to prove that y dash lies on the circumcircle of MQX.
Okay, we can also do like that. Yeah.
Like
Yeah.
in addition to this, we need that.
No,
No,
it's the same
these two
thing.
imply that, like
No,
this.
no, these two imply that.
There's like a point over here which has the same thing.
Right? What?
Oh,
Because isn't
like
Y dash QX, what do you
Yeah,
say?
this is like I think this is
Bisector of
fine
that
unless
going to be a unique line? Like wherever that intersects BC would be a unique point.
Okay, yeah, right.
So there's no other point on that would satisfy.
so y dash qm is y dash qh, right? Yeah,
Y
and
dash Q Y dash QM is Y dash QH. Yes.
it is y dash ah.
it's y dash
Y
AH.
dash
Yeah.
A. Wait,
Why is it y dash QH?
I mean qmh collinear.
QMH
Oh,
collinear,
okay, I thought it was minus. I don't know.
which is Y dash AH.
So y
Yeah,
dash.
yeah, okay. Obviously.
So we
Uh,
want to show y dash ah is equal to mqx, which is if we'll draw antipode now. We'll draw antipode then the qhm a dash collinear. So mqx equal to a dash qx is equal to a dash a. So you want to show wait what? Okay, wait, that implies ay dash as collinear.
A
Right?
Y dash S collinear.
Like what we want is that h a y dash is equal to x a dash.
XA, yeah, XA Y dash is equal to XA.
H a y dash
H,
equal to x a dash. Like follow me like one.
yeah, yeah, I see. Because
And
H, hmm,
so that would imply that ay dash and am are isogonal in h a dash, which means in isogonal in BAC. So ay dashes should be collinear. So like I think you should like probably change
Wait,
the
how have you
diagram.
defined y dash? How have you defined y dash?
Y dash is AEF circle intersect BFS circle intersect C.
Oh, okay. Yeah, there
C.
was also like you showed AY dash as collinear, right?
We just showed right now. Yeah. Like
Yeah,
no,
but you can also
sorry.
POV
No, we
like
showed that that's what we want.
We sure that's
oh
what we
you
want.
showed okay.
Okay, wait.
AH is a median, right?
I'll just
A,
redraw S because like it's
AS
supposed
is
to be.
Yeah, also S like should lie on the other side. That's what I was saying. Like it should lie on the other side of AH.
Hmm. So this is what S is actually supposed to be. So we have to show that S lies on that.
Yeah.
Y dash. Yes.
Yeah, and that should be like that's power of point. Yeah, that's just power of point.
That's just PowerPoint.
Let's
Like,
take AS and take Y dash so that
yeah, because yeah, BCEF cyclic. So
Yeah,
hmm.
exactly.
AF,
BCS.
so A lies on, what do you say, radical axis of BFS and CSE.
Okay, so that
Hmm.
proves this part. This part proves the angle bisector part.
Yes, that proves angle bisector part.
The angle chasing. So next we need my dash equal to max.
Yes, or we could have the cyclic condition,
Hmm. Okay, which
because I
is
think we know angle Y dash QX now, right?
y dash qm we know, yeah, and y dash qx as well.
Yeah, because so that just tells you that Y dash
So we
Q
need to like get something about y dash
Y dash.
m a or something.
No, I was thinking computing Y dash MX.
Yeah, like y dash
Ah,
mx is
okay.
greater than y dash ma.
Hmm.
Wait,
See,
wait,
basically, you just want to show Y dash MA is equal to Y dash QX. What is
wait.
Y dash QX? That will be 2 times Y dash QM, which is Y dash QH, which is Y dash Q. So you just want to show Y dash is angle. What?
What?
No. You want to show 2 times Y dash AH is equal to Y dash MA.
Yeah, yeah.
Right? Let me just
Two
write that
times
down
y
quick.
dash ah. That's not
2 times Y
this is
dash AH is
Then we
equal
can
to y dash m a.
yeah.
Mm-hmm.
Okay, y dash has some. Okay, we can take this. We can do this now. Like, okay, consider this point. Like, consider the Humpty point.
Okay.
Like AM intersection A here.
Mm.
Then y dash HAMS cocyclic. And we know that MHA is equal to MX. That's known because far off point.
Yeah.
Like, yeah. MH or like
Yeah. MHA is equal to MA.
MX. Yeah, so what we need to show is that MH is equal to MY dash. So we just need to show SM is the bisector of HASY dash. Or whatever.
Okay, wait, this is trivial, no? This angle is 90.
Which angle is 90?
Oh
Okay.
yeah. Wait. No. What?
No, no,
What?
no, it's
No,
not
no, no,
90.
no.
No.
I got confused.
HHA will be 90,
Yeah.
not y dash.
So we know that MS Y dash HA cyclic.
MS y dash h. Yeah.
And we need to show that MY dash equal to MHA.
Wait. We need to show m. Wait. Can you repeat what you just said?
Like
To
follow
prove
me.
my dash equal to MHA. Yes.
Like, this is what
Uh. Yes. So that. Wait. What? Because that's telling MHA dash. That's telling HASM is 180 minus HSM. So
wait,
HA.
HASM you mean? Wait, what?
Yeah, like Humpty A SM. Like
Hmm?
you want to show this angle equals this angle, but now this angle is 180 minus this angle. So that's this angle. And so you want to basically show that these two angles are equal.
So like angle bisector, right? The BC is the angle bisector of Y dash S Humpty.
BC is angle bisector of Y dash S Humpty.
Because circle and perpendicular equivalence, right? MY dash equal to MHA.
Oh,
MY dash equal to MHA and SY dash HA M cyclic. So it must be angle bisector.
hmm.
Right. So that's what you want to show. Yeah.
I'm a little bit confused on the finish. How did you show that BC was angle bisector?
I didn't show it. I'm saying that's what we
Oh,
need to do.
oh, that's what we need. Okay. Then I'm fine. Yeah. I got
Okay,
it onto that as well. And I was confused because I thought you got BC's angle bisector.
okay. Now I've got BC angle bisector. Like it's this. Like we know this, right? That if X dash and HA are reflections in BC.
X dash and wait,
X dash are reflections in
X dash. Wait. We have some X dash here. Okay, X dash is AS.
X dash and HA are reflections in BC. That's like
Yeah. Humpty.
so. Yeah, like ASB is equal to X dash SC is equal to HASC. So done.
Oh, because you're just reflecting.
Yeah. So
Yeah.
ASB
Okay.
X dash SC is equal to HASC. So SCM bisects Y dash SHA. And because that's
Yes.
cyclic, MY dash equal to MHA is equal to MX.
Yes. So you're done.
Okay, that works too. But what we like,
Intended
yeah, that
solution.
the finish was different. You had y dash HASM cyclic, right? You proved that.
Yeah.
So and observe SM is parallel to X dash X.
Where's S dash?
Uh,
X
uh,
dash X
X.
dash
Yeah.
I because they're isogonal.
Hmm.
hmm.
Like BC is parallel to this because they're isogonal. So by reams you get y dash HA X dash X also cyclic.
Yeah.
Oh. I see.
But now because looking at the 3 points HA X dash and X M must be the center. So you get
Oh, okay.
Oh.
MHA equal to MX dash equal to MX. Right.
yeah. So M must be the center.
Hmm.
So y dash should also satisfy this. Yeah.
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 Yeah, so that is why I was actually a bit like, oh, should have introduced X dash at the very start because that is the point we introduced at the very end. But yeah. Like Aditya, when you just saw the problem, you just introduced X dash. Yeah.
Yeah. Nice. Nice. Nice.
Now next is
P P6 P6 P6. Where is the problem? Not yet. Yeah. Geos were nice. It felt nice solving them at least. Oh no.
what is it? Like, is inequality?
Let A, B, C be integers in interval. That A equals B equals C.
Okay, so ABC divides cube B plus B
That's
cube
B cube C.
C plus C cube A. So that would imply AB divides B cube C plus C cube A, and similarly.
Yes.
So if I multiply this side by A, then I get AB divides A square C cube. B divides
Yes.
AC cube. Okay, that was just direct from here. We didn't need to do all this. You can directly say that
Mm,
B divides AC cube.
C cube. Mm-hmm.
Hmm. How do you use the fact that it's n plus root m by 2?
Yeah, that seems kind of cursed. Um,
I think what we can do is like you show, okay, maybe not entire ABC, but say just ABC divides some expression, and like the expression has some minus signs in between. Like here, the point is A cube B plus B cube C plus C cube D is just too large. But if we, something else
uh-huh.
with minus signs in between, and that we show is small because the numbers are very close to each other.
Hmm.
For
Oh,
example, like
wait. How about
A
A
mi-
cube B minus A square BC? So then you'll have
Yeah, that's mere head.
like
yeah, because
I
like
just subtract
these
so
at max square root 10. So you know ki A minus B squared is
It's a
like
very
at
good
max.
minus.
and like I'll subtract A square BC
Okay, wait,
and like
you also
B.
subtracted.
Okay, sure, sure. Yeah. So now the point is I just take out A. So like this will just be A square B times A minus B plus B square C times B minus A. This will be minus C. A minus C. And like this will be C square A times C minus B. So like we have ABC divides this.
And also what the condition says is like A minus B squared is at max like A by 2. Yeah, A by 2, B by 2, C by 2. Wait, I'll
But
write.
kind of bad somehow. But we don't have it.
A minus B squared is at max like not ABC but min of or it.
Yeah, like maybe for wait. What if you look at this summation? No.
Wait,
ABC by
maybe you
2.
want to subtract a little bit more. Like if I subtract A minus, oh no, that's just doing nothing more.
Wait, we'll just maybe force this summation. Like look at this summation or something. Let's look at this summation. This is not exactly fine. Not exactly this. Something like this.
Yeah, it's this thing only. Like this
So like
is
we don't have ABCs here. We have the extras are A square, B square plus B square, C square plus C square, A square. Right, and that's not what we want.
hmm. Yeah. No, I was thinking we subtract A minus like minus A minus C times A B C. Like now I take A minus C A B out, so I have another A minus C term. So this is just A minus C squared times AB, right? Is that
Wait,
correct?
what are the summation you're taking it exactly? I didn't get.
Like I'm using this already, and now from this term I subtract a minus c times abc. Here I subtract
Okay.
b minus a times abc.
Wait,
Like
that's changing nothing. That's just adding zero, right?
yeah, that's adding 0. But now this thing I take AB, A minus C common. So now I have A minus C whole square times AB, right?
Okay, so we're essentially looking at this summation then.
Yeah, it's just this thing, but C, not B. Yeah.
Yeah, that's. Wait, is that like almost done or something?
I don't think so. It's a P3, P6, man. Like, don't think we'd be already almost done.
Okay, look, we are close. It's close.
Okay, fine. I will trust you on that.
I mean, like,
C
wait,
minus
this
B
summation is divisible by ABC, right? That's
is
fine.
divisible by ABC.
See, and okay, we now know that a minus b squared is at max min by
Yeah.
2. So
So
it's
that's
like
like at
now
most 3ABC by 2.
Oh, yeah.
it forces it to be ABC unless like ABC is very small. But I don't think ABC can do
No,
so.
no, this is just ABC. This is just equal to
This is
ABC.
just equal to ABC.
Oh, right, you have 3 by 2. Okay, yeah, it's right.
Yeah.
Okay, so this has to be ABC.
Or it could be 0 or
No. Like all that's what you want to show. You want to show it's all zero.
yeah, yeah. So okay,
It
so
can't
for
be
the sake,
0, right? All terms are positive.
You want to show it zero.
we want to show
This
it
is also
0.
equal to this.
Yeah, got that, got that.
Oh, right, sorry. 0 unless we assume not. Yeah.
Unless we assume not. Yeah, that like like I forgot we went to for the sake of contradiction, but
This is like
surely
Go.
that's weird. Hmm.
A divides b squared c and so on. If that helps.
Like yeah, I'm thinking like A divides this thing, so maybe can we say something like that? Because like that means that A divides BC times B
it divides
minus.
B cube C, which you already knew.
B
You already knew.
cube c.
That is a
I think, yeah, I don't think we should go back to divisibility. I think this is again going to be some
Yeah,
size or something.
like we have size.
size. Okay. Like what's this? This is
Can be.
ABC are like they can't have a universally common factor. Like can't have GCD of A comma ABC is 1, right? Because or no. Is this
Uh,
mm, no, that's not
see.
that's not
See this bound here should be pretty. My thinking is
okay, wait, maybe we can look at like this. Like if P divides A, B, and C, all three of them. Okay, and let's say like VP of A is at least VP of B is at least VP of C.
okay.
Then yeah, then like each of these numbers, each of these three numbers is divisible by VP of A, P to the VP of A plus VP of B plus 2 VP of C. Right? Each of these three numbers, but the
yeah,
VC is not. So VP of C is equal to 0. So no prime can divide all three numbers.
the terms just have
Oh,
too high VP. That's the point.
What?
The terms have just no wait. Wait, how can I start with the second term? Uh,
because
Like,
that's just VP
like
of A plus VP of B plus 2 VP of B.
so like
so
Sorry,
if
second,
VP of B plus VP of C plus 2 VP of B. Huh.
we don't
okay,
have.
no, we can't say that. We can't say
We
that.
can't say that. We can't say
No,
that.
I think
No,
it's
no,
still
the
like
VP
huge.
was too low or something. Like, I don't know. Like, these two VPs are greater than the VP of ABC.
Yeah,
And
okay,
Yeah.
okay. Then,
okay,
then,
it's not.
then these.
So, this must be. This has VP this. So, it can't happen. Or it can happen. No, it can happen.
It can happen. You just have VP of A is greater than equal to 2 times VP of B.
Wait, no. What we must have is this is equal to VP of B plus. Okay, like, this expression must be true. Right? Because. Or no. Okay, no. I decided.
Wait, even if we show GCD ABC equals 1, that does not even help.
Like that
Yeah.
seems like a worst case scenario because you can all like if P divides ABC, then like the case where P doesn't divide any of them will like satisfy for like M by P, right?
GCD ABC equal to 1 would like finish, no? Because then A would divide BC into B minus A whole square.
GCD being one means that, but
But again,
Okay,
anyways, you need
no.
to have an argument for B, GCD being one, right?
no. Just because net GCD is one,
Yeah, they are not pairwise.
that doesn't mean that A is coprime to B and C.
Yeah.
Yeah. I'm trying to see is if we can optimize this sort of argument, like if like less than equal to 3ABC, like first of all we can say that's less than 3ABC strictly, although that doesn't help us too much, uh, because the m by 2 is not included in the set, like under root m by 2. And what I'm trying to see is like largest element, right? Like the largest element would probably be very close to m times root c by 2, right? So that term would certainly vanish, like m by 2 by 2 m by 2. Let me just say that this is by 2.
Wait, what? Some term is wait. Huh? What?
What?
Some term. No, one second. I'm trying some idea. I didn't have a pen. I can't draw. Ah, okay, got it.
So sort of ABC have to be close to each other, right? They can't be too far, which already knew.
Times ab plus bc plus ca, right?
That is
M
nice.
equal to
Also, it's like sum to A, like things should be far apart because out of these three terms, at least out of one of the three terms must be at least ABC by 3. So, like, just assume the first term, and you get like maybe you get like A minus C squared is at least M by 3.
Yeah. But and at most M by 2. Yeah.
That's also at my M by 2. So it's like A and C are pretty far apart.
A and C are pretty far apart. Like it would be nice if we can show AB plus AC is less than BC. Is that too much? That
B
seems like way
plus
too much. I am being way too weak.
A and C are so far apart.
Optimally, actually, you would want B and A to be close and then C to just be really far apart, right? Like you just have A and B are like close to M and then C would be uh, M plus root M by 2, like almost, is what we'd probably want to argue, right?
Okay, maybe we can do it like this. Like let's assume A less than B less than C. Okay.
Yeah.
Then let's just assume this distance is some x and this distance is some y. Then we can get some. What's this looking like?
Then this will be x plus y whole
Into
square.
y whole square.
So this will be x plus y whole square. This will be x whole square, x square, and this will be y square.
Yep.
Oops, y, just y. Okay.
It's like x plus y is large. X plus y is at least root M by 3. And you also know ki they have to be close.
Okay.
So, like, some two numbers must be close. So, x or y must be small. But
Oh,
then it's like,
x square plus y square is less than x plus y whole square, right?
yeah.
Yeah.
But we know that x plus y would be less than equal to m by 2. So I'm trying to see if we can. Oh no, that's useless.
X plus y is at max root of M by 2. And
Yeah.
at max M by 2, it is at least root of M by 3.
So x is
It
at
will
most
be
m
x
by
plus y
4.
by
Like
What?
x. No. What am I saying?
Shouldn't
X
this be
square.
x plus y by 2?
Like actually root m by 3 is like a weak bond, right? Because if x plus y is root m by 3, then x and y both have to be large. It will make x plus y 2 root m by 3. Right? So if like x plus y is too large, then x and y if it's close to root m by 3, y, then AB into x plus y square is like roughly a third, right? So one of these two other terms have to be large as well. So like you need to like look at the largeness like together or something.
Yeah, that sounds
Shouldn't this be
fine.
x plus y by 2 instead of x plus 1?
No, it should be x plus y. Like it's c minus a.
Okay.
Like a minus c, whatever. X plus y square. This is less than. This is
But
c.
do you think we should consider some other expression, not necessarily this?
Oh wait. See, AB is less than equal to BC, right?
Yeah.
CA is less than equal to BC. Okay.
We did.
And
Why did you do CB? One second.
wait.
What
Maybe
happened?
write again. Don't edit that
Wait. I think that might be, yeah. Okay. Cool. Wait. Oh, there's no space. Um. Okay. So AB, we have AB. We have AB times x plus y whole square. Okay. Plus BC times x square. Plus CA times y square. Okay. Now the point is this thing is less than BC times x plus y whole square plus x square plus y square, right? Because this is less than equal to BC, this is less than equal to
Yeah.
BC, this is less than equal to BC. Okay, but now x square plus y square is less than equal to x plus y whole square, right? So I can say that this thing is less than equal to 2 times BC times x plus y whole square,
When x
right?
plus y was equal to by 2.
But x plus y whole square is at most m by 2. Okay, so this thing is at most mbc. In fact, this is strictly less than m by 2. So you're
So
done.
you get this is
Not strict, not
MPC.
strict, not strict. Like the
No, it is strict because m by 2 is not included, right?
Ah,
M by 2 is not included in the region.
strict. So
okay.
So you're just done,
yeah, we're done.
right?
Yeah.
Yeah, we're done. Yeah.
We're
Yeah.
done.
Yeah.
Oh,
Okay, nice.
it's not, you just observe this. Oh, wait, that just works. But that seems
It works,
weird
right?
That is-
because x. Oh,
Yeah, it works.
it
Unless it's
works.
zero, and there's zero cases when we all are zero. And
Yeah, we're done. We're
Okay,
done.
okay.
actually, even that case is fine. Actually,
No, like I'm saying, where did we miss? Not miss, but like where does the solution come from?
Like
It's
this is just if it's a, like we just have that this summation. Where did the
can't
term
be.
go? Like we have
Yeah,
this thing is strictly less than ABC, but we
yes,
know
it
that
can't.
ABC divides it
Yeah, yes,
and
it's
it's
zero. Okay.
positive, so it has to be 0.
Yes.
It's just division size. And
Yeah.
obviously, if this thing is 0, then we have that a minus c is 0, b minus c is 0, c minus a is 0, and that's what we wanted. Yeah.
Yeah. Okay.
Yo,
Yeah, I think.
that's so nice. That's I actually like that problem.
Okay, we finished it in 1.5 hours. I think that's good.
Yeah.
Really? Oh, we did. We did. Nice. Day 2 took
Uh,
us like almost an hour. Day 1 was like 45 minutes.
no, I think B2 took the most time.
Yeah, just like I mean, very Oz proposals. Like it just couldn't be done faster.
No, I'm talking about day one P2. Day
Oh,
one
day
P2.
1 P2. Oh yeah,
Day
day
The D2,
finished pretty
right?
quickly.
day 1 P2
Section
we
like
actually finished. Like I mean, working on the date.
did we
Like
do?
still we were done by 7 for day 1. Day 1 we were done by 7 p.m.
Yeah. Day two took one.
Day 2 took more time. But like Yeah, I keep thinking of problems in terms of like P1, P2, P3, and then repeat. I'm so sorry. Okay.
Mhm.
This was nice. I like this one.
Yeah, okay, I think I just checked the chat once.
Oh, what happened? Let me read chat. I saw like I read the
Okay.
initial bit, and then I was like, oh, is there any combi problem? There was combi problems. Where did combi go? P1 was combi. Does P4 count as combi?
No.
P1 was clear combi.
P1 was, I mean, it was like,
Isn't it
P1 was
supposed to follow
combi.
yeah. Okay, P1 was only combi, I guess.
P1 is only combi, like it's
So
just
like,
subsets.
like P1, P2 are supposed to be distinct subjects.
Yeah.
That is, okay, is that
At
satisfied?
least
this is an
general.
NT.
P2 is algebra. P2 is algebra.
Which P2? Okay, P2
P2 is algebra or NT?
okay, P2 should be NT if we want
NT.
P4 to be algebra. Like P4
P4 is algebra.
P4 is algebra.
Yeah.
Yeah, true. Okay,
One
then
P3
P3
should
is
have been
geo.
combi.
P5 is geo. What is P6? P6 is just
P6 is
algebra.
NT.
P6
Oh
is
yeah,
algebra.
P6 is algebra honestly, because all you're just doing is manipulation. Like
Okay,
there's some
true.
divisibility
You're not
stuff.
using any properties.
And like it's like
Like you're using A divides B and B less than A is implies B equals 0
Yeah, I think this is what is like size. So
size.
yeah.
It's NTL, I guess. I mean, you're really not using any NT theorem. Like we didn't need the VP stuff, right?
Let's call it AN.
if
And
you get A then P4 is A, that's an issue. Or is it an issue?
it's not like, do they really care that much?
I mean, we can assign it so that they're all distinct, like C,
See,
A,
they call TSTP1 as a
G.
combi, bro. Like that's clear geo.
TST had like very little combi. They should have added one more combi.
No, I mean practice TST was just combi. No, like I think P1 and P3 was combi. P1 is
Yeah,
combi.
but those are
Yeah.
like not
Yeah,
very
so
good.
they just put all the combi in practice TST and was like, nope. Mm,
Okay, I think then we can stop the recording.
okay,
Yeah.
I will. Okay, we're going to have to figure this out.
Vital essence.
But I can stop it here. End stream. Shall I end
Yeah,
stream?
just
I
yeah,
stopped
just
it.
the current.
I stopped it already.
Oh, you start.